deep inside a northern Nevada volcano.
The U.S. is sitting now on one of the largest lithium reserves in the world, but NASA doesn't want much of it touched.
The McDermitt Caldera, a massive geological structure straddling the border of Nevada and Oregon, is emerging from obscurity as one of the most closely monitored volcanic systems in the United States. Unlike the more famous Yellowstone caldera, McDermitt has operated largely outside public awareness, but recent studies suggest it could become a major geological concern. For decades, this region was thought to be in deep geological slumber, a relic of an eruption that occurred over 16 million years ago. However, new data paints a picture of slow but unmistakable reawakening. Satellite imagery and high-resolution GPS tracking indicate that the ground in and around the caldera is rising, not in a symmetrical dome as might be expected, but in a lopsided pattern concentrated along the southeastern edge. This asymmetric uplift is not merely a surface anomaly, but hints at deeper pressure changes caused by the movement of semi-liquid magma within ancient fault lines and fractures. Scientists believe that this irregular inflation suggests a migrating magma body pushing through weakened areas of the crust, seeking paths of least resistance. The geography of the McDermitt region adds further complexity to the unfolding narrative. The caldera lies at a volatile tectonic crossroads where the Basin and Range province meets the northern volcanic arcs. Here, the Earth's crust is actively stretching, creating new fractures that can serve as conduits for rising magma. These fractures form a structural vulnerability, exacerbated by the intense heat generated from deep within the mantle. As the surface is pulled apart, it creates ideal conditions for magma and other heated materials to rise toward the surface, potentially reactivating long-dormant volcanic systems. The convergence of tectonic extension, crustal weakness, and subterranean heat has created what scientists consider a perfect storm, a scenario in which even subtle geophysical changes can lead to significant geological events. To analyze these changes, researchers have installed a network of advanced instruments across the caldera. These include GPS stations and borehole tilt meters capable of detecting ground motion on the millimeter scale, along with satellite radar interferometry, INSAR, that creates detailed models of surface deformation. These tools collectively confirm that the uplift is not a random or short-term phenomenon, but part of a consistent long-term trend. Alarmingly, the pattern of uplift bears resemblance to early warning signs observed in other reawakening volcanic systems, such as Campi Flegrei in Italy and Laguna del Mal in Chile, both of which exhibited asymmetric swelling and heightened deformation before entering periods of volcanic unrest. In those cases, seemingly minor surface changes were harbingers of much larger subterranean developments involving the movement of magma and pressurized fluids. Thermal anomalies in the region provide another layer of concern. Scientists have deployed drone-mounted infrared cameras to conduct localized thermal mapping, identifying eerie patches of heat in areas that were once considered geologically inactive. These thermal signatures are not random, but cluster around old fumarole fields and mineralized ridgelines. Ground crews using handheld sensors and soil gas analyzers have found elevated levels of carbon dioxide and hydrogen sulfide, gases often associated with deep magmatic activity. The distinct smell of sulfur in some locations further reinforces the suspicion that volatile gases are escaping through the fractured crust, providing a subtle but important indicator of internal unrest. Adding to the growing list of warning signs, magnetotelluric surveys have identified low resistivity zones deep beneath the caldera. These electrically conductive regions suggest the presence of hot, saturated rock or possibly even molten magma. The existence of such a reservoir just a few kilometers below the surface implies a level of subsurface activity not previously suspected. Rather than cooling down, the caldera seems to be undergoing a quiet reactivation. The anomalies are not confined to a single area. Instead, they appear to be spreading, gradually infiltrating new sectors of the volcanic field. Researchers describe the current situation as a hydrothermal engine sputtering back to life, a system of stone and steam that may be transitioning from dormancy to activity. This raises the possibility of not just geothermal energy development, but also significant geological hazards. Seismic activity in the area further reinforces these concerns. Temporary seismic arrays arranged in concentric rings have provided a much clearer picture of underground movements. These devices are sensitive enough to detect quakes as small as magnitude 0.1, and over the past several months, they have captured a pattern of recurring seismic swarms. These tiny rhythmic earthquakes cluster around the zones of maximum uplift and occur at depths between 3 and 7 kilometers, precisely where molten fluids often migrate into brittle rock. What makes these events particularly unsettling is their repeatability. Identical seismic signatures have been recorded in the same locations within short intervals, suggesting a buildup and release of pressure in the exact same spots. This is not the erratic shaking typical of tectonic stress, but a patterned, almost pulsating signal indicative of subterranean magma movement. These repeating earthquakes are often triggered by external environmental changes such as atmospheric pressure drops, rapid snowmelt, or fluctuations in groundwater levels. This implies that the land is teetering on the edge, sensitive not only to internal forces but also to minor shifts in surface conditions. The interplay between external and internal triggers creates a volatile situation situation in which even minor events could catalyze significant geological changes. In the context of ancient volcanic systems, it is rarely the loudest shake that signals danger. More often, it is the persistent, quiet tremors that precede dramatic outcomes. Mineralogical data gathered from lithium exploration efforts in the region has inadvertently contributed valuable insights into the caldera's current state. Drill cores extracted from deep underground show layers, rich in clays, altered volcanic glass, and rare earth elements, all markers of prolonged interaction with superheated fluids. Of particular interest is the transition of smectite clay into elite, a process requiring sustained temperatures of at least 200 degrees Celsius. This transformation acts as a natural geothermometer, suggesting that a robust heat source has been active for an extended period. Geochemical analyses reveal elevated concentrations of boron, lithium, and arsenic, elements commonly mobilized in hydrothermal systems and indicative of magmatic degassing. Isotopic studies further bolster the case for renewed activity. Deviations in oxygen-18 and deuterium values from typical meteoric baselines point to deep-sourced fluids interacting with surrounding rock. These isotopic signatures resemble those found in known geothermal hot zones such as Iceland and Kamchatka, both of which are prone to significant volcanic eruptions. Taken together, these mineralogical and geochemical fingerprints suggest that McDermitt may have maintained thermal activity into the Quaternary period or experienced a reactivation in recent decades. This would place the caldera within an active geological framework rather than a dormant historical relic. The broader geological context of McDermitt reinforces its significance. It belongs to a linear chain of calderas that trace the ancient path of the Yellowstone hotspot as the North American plate moved over it. As the continent drifted southwest, the hotspot carved a trail of increasingly young and volatile volcanic features, starting with McDermitt and culminating at present-day Yellowstone. Recent satellite gravimetric analyses have uncovered mass deficits beneath several of these calderas, regions where dense rock appears to be missing, possibly replaced by partially molten magma. This revelation suggests the existence of an underground magma conduit linking McDermitt to other calderas along this volcanic corridor. Structural mapping has identified fault systems connecting McDermitt to nearby volcanic areas like Steens Mountain and the Owyhee Plateau. These faults could serve as subterranean highways for magma or superheated fluids, raising the possibility of multi-site reactivation. Some of McDermitt's older lava domes, once thought geologically inert, are now exhibiting subtle signs of uplift and surface degradation, potentially driven by renewed internal pressure. These observations are not purely academic, they carry real-world implications for the surrounding communities and the broader region. The scenario of a volcanic eruption at McDermitt is no longer considered entirely hypothetical. Even a moderate event could have catastrophic consequences for Nevada, Oregon, and neighboring states. Thick ash deposits could bury infrastructure, contaminate water supplies, and disrupt transportation networks. Air traffic across North America would be thrown into chaos, and solar panels, livestock, and agricultural systems could be severely impacted. A large eruption might initiate a volcanic winter, reducing global temperatures and triggering widespread crop failures. Such an event would resonate through the global economy, affecting food security and resource availability far beyond the immediate blast zone. The last time an eruption of this magnitude occurred in North America was approximately 640,000 years ago at Yellowstone, leaving behind a scar that is still visible from space. Given that McDermitt was born from the same mantle plume, the possibility of it following a similar path cannot be discounted. Scientists are therefore focused on readiness and monitoring, recognizing that the Earth often gives minimal warning before dramatic geological events. There would be no multi-day alerts akin to those preceding hurricanes or tornadoes, only the quiet, escalating signals of tremors, gas emissions, and shifting ground. Researchers are also beginning to contemplate the broader implications of a reawakening at McDermitt. Could this activity set off a chain reaction along the ancient volcanic corridor that crosses the American West? The region contains more than a dozen massive calderas formed by the same hotspot, many of which are believed to be dormant. However, they share common tectonic characteristics and rest on the same mantle plume. They are interconnected through fault systems capable of transmitting stress and magma over considerable distances. A domino effect of volcanic unrest, while rare, is not without precedent. In geological systems like New Zealand's Taupo volcanic zone, activity at one site has been known to influence others. This possibility has turned McDermitt into a focal point for volcanic research. The more scientists investigate, the more they uncover signs that this ancient scar in the earth is not as dormant as once believed. It serves as a stark reminder of the dynamic forces at work beneath our feet and the delicate balance that sustains modern civilization. As researchers delve deeper into the mysteries of McDermitt, they are piecing together a complex puzzle of tectonic activity, magmatic resurgence, and structural weakness. Each new discovery adds urgency to the question not just of whether McDermitt is waking up, but of how prepared we are if it does. This growing understanding also highlights the importance of continuous monitoring and public awareness. While not every volcanic stir results in an eruption, ignoring early warning signs can have devastating consequences. Advanced technology and interdisciplinary research offer humanity the best chance of predicting and responding to such events, but only if those insights are acted upon. The earth beneath the American West is shifting, whispering secrets of ancient fire and modern threat. In this moment of uncertain potential, staying informed is not just wise, it may be essential for survival. McDermitt stands as both a geological enigma and a cautionary tale, urging us to listen carefully to the subtle murmurs of a planet that never truly sleeps.